So a ball is dropped from a height of 12 feet. Each time it hits the ground, it rebounds to 3/5 of its previous height. Find how far the ball will travel before coming to a stop. So let's draw the whole situation, guys. Let's draw the floor. Let's draw the ball, which is 12 feet from the ground. So this initial height is 12, right? And we will drop it. Okay, we will just let go, basically. We're not gonna throw it downwards, neither upwards. We're just gonna let go of the ball. Okay, and so the ball will go downwards, and it will rebound to a certain height, downwards again, like so. Okay, like normal balls behave. Okay, so they want me to the find how far the ball will travel before coming to a stop. So basically, guys, they're asking you to find the total distance traveled by the ball. The total distance traveled. Okay, as it goes through this motion like this, and then bouncing back, and then once again, and so on and so on and so on until eventually it stops. So what you need to realize is the following. Let's write the first height of the ball. I'm gonna write h1. Height 1 is gonna be equals to 12. Height 2, which is gonna be the next height in the after the first rebound, right? That's gonna be 3/5 of this, so it's gonna be 3/5 of 12. And the height 3 is gonna be 3/5 of this, right? Of all of this, so it's gonna be 3/5 times 3/5 times 12, and that can be written very neatly in this way: 3/5 to the square times 12, and so on for the rest of the heights, right? So for the height number 4, you're gonna have 3/5 to the cube times 12, and so on. So you can see that this is basically a geometric sequence, right? 12, and then 12 times this, 12 times this to the square, and so on. We're always multiplying by 3/5. So what we want to do is this, guys. You need to understand that the total distance traveled is all the the length of going down and then going up plus going down again plus going up plus going down plus going up plus going down, and so on and so on. Okay, so basically, if you want to see that in a horizontal way, what you would see is this. The motion is not really traveling like this. You need to understand that the ball is not traveling this way. The ball is traveling downwards. But I want to represent the successive bounces in this horizontal way so as to avoid confusion. So this is the second bouncing, right? And then the third, and then and so on, like this, right? And so on and so on until it will eventually stop after many bounces. So this height is this one. It's the height 2. This is the height 1. This is the height 2. This is the height 3, and so on. So basically, what we need to add is this. We need to add the height 1 plus 2 times the height 2, because you need to take into consideration when the ball is going up, that's one height 2, and when the ball goes down, that's another height 2. So you need to sum these twice, and these twice, and these twice, and these twice, and so on. You see what I mean? So basically, forget for a moment, forget for a moment about h1, about this part of the distance. Okay, forget about this, and just suppose that the ball goes from here to here, and then downwards, up, downwards again, upwards, downwards, and so on, as though h2 is the first term in this sequence, right? Forget about this for a moment. So suppose h2 is the first term. It's going upwards plus going downwards plus going upwards plus this, and so on. So basically, what we need to add, guys, is all the terms starting from h2 all the way to infinity, right? And is there a way to do so? Yes, with the formula that we just found. The sum of all the terms of an infinite geometric series is going to be equal to the first term over 1 minus the ratio. Remember, we are forgetting about this for the moment, and we're just going to suppose that h2 is the first term in this particular sequence. So I need to replace u1 by h2. There it goes. 1 minus the ratio, which is 3/5, as we can see. And that guarantees that I can use this formula because the ratio is between -1 and 1, right? So h2 is going to be 12 over 3/5. I'm sorry, 12 times 3/5. Okay, so let's calculate all of these guys. We're going to get 36 over 5 over 2 over 5. Is that right? Yeah. I'm going to continue over here. Equals, this is going to be 18. Make sure once you carry out this operation, you're going to get 18. But once again, what is 18, guys? 18 is when you start counting the distances from right here. Like it's going to be this going upwards plus this going downwards, upwards, downwards, upwards, downwards, and so on until eventually the ball stops and is at rest. That's going to be 18, the sum of all of these blue trajectory. But then you need to add this other bit in here, which is the original height from which the ball was released, which is 12 feet, right? So in the end, my conclusion should be this. Conclusion, conclusion colon, the ball traveled 18 from here plus this 12, 30 feet overall. Okay, so that's the conclusion to this problem. I need you to understand this problem deeply the way I did it, and if you have any question about it, tell me in a moment, right? So let's stop this video for the moment.